Okay, welcome to this video lecture on basic surveying. Now today in this lecture we are in module 9, which is on computation and adjustment, and we will be talking about the lecture number 5. So what we know right now about the adjustment is that we can carry out the adjustment by observation equation method and the condition equation method. There are some more ways of doing it, but right now for this video lecture we'll restrict it to only these two methods. Now any problem can be solved by either of these two methods, but sometimes the problem is, we can solve easily one problem by a particular method from either of these methods. Now we will see today some examples of these two methods, the condition equation method and observation equation method. Or rather, what we will try to do, we will try to solve one problem by both the methods. Okay, the important thing, as I discussed in my last lecture also, important thing is how to frame the basic equations, how to see the conditions in our, or how to frame the basic model, the stochastic model and the functional model. That is most important. Later on, as we have seen, the solution is just matrix manipulation. Then finally, towards the end of this lecture, we will see one specific problem, which is the base quadrilateral. Very often whenever we are in field, we are doing the triangulation, we have to go for a base quadrilateral, a very important figure. What is the procedure for adjustment of that? So this also we will cover today. Fine. Our first example is, over here there is an observation point O and 2 points P and Q are there, and as well as R. And what we have done, we are observing the angle A by theodolite as well as angle B, and also we are observing the angle C. Now in this case, the observations are A, B and C. Well, what is the job, what we desire from this? This particular problem, the desired thing right now is only A and B. Someone wants to know the angles A and B, okay? But while he is taking the observation, in order to include redundancy, he also takes that full angle C. So he is taking 3 number of observations. So we can say n number of the observations are 3. Now the desired thing is angle A and B. So we can say A and B, these are the desired. I am writing A hat and B hat to differentiate them from the observations A and B. So these are the unknowns, these are the parameters which we want to determine for this particular model. So we need to carry out minimum number of 2 observations in order to find a solution for this model or for this problem. So the R is 3 minus 2, which is 1. Now what we will do, we will try to handle this problem of adjustment, because naturally we need to carry out the adjustment here. We have A, B and as well as C. So we will need to carry out the adjustment so that we have the most probable values or the best estimates for A and B. Now what we will do, we will do it first by observation equation method. Now in this observation equation method, we know, if you recall our last to last lecture, that we write the observation equations in which we include the observation as well as the parameters. Okay, all are included there. Then for each observation we write one equation, and finally we write it of this form: V plus B delta is equal to F, and one equation for each observation. Now what we will do, we will write the same thing over here. First of all, for observation A, so we can write A hat as A plus V1. What is V1 here? V1 here is the residual or the error in observation A. Alright, then we can write for B hat, A hat and B hat, these are the parameters here, these are the unknowns here, is B plus V2. Similarly, now for this total angle, can I write this total angle, that is C, in terms of my parameters or the unknowns? Well, I can write it as A hat plus B hat is equal to C plus V3. This is important here, what we are doing here. What we have observed that full angle, and that full angle is nothing but A hat plus B hat, and that full angle, the value of that is C, and in that C there is some error, V3. So this is how we are writing it. Now we will rearrange it so that we bring all the V terms on left hand side. So we can write it as V1 minus A hat is equal to minus A. Similarly, V2 minus B hat is equal to minus B. What I am doing, this A is going here and A hat is coming here. So V1 minus A hat is minus A, and V2 minus B hat is minus B. Then similarly, V3 minus A hat plus B hat is equal to minus C. Now we have to write it finally as we saw in this form: V plus B delta is equal to F. We have to write it in this form. We know that in our observation equation method we reduce our equations to this form. So how we can write it here? Our residuals here are V1, V2 and V3. So if I now write this in matrix form, so what we will do, our parameters are A hat and B hat. So we can write it as now this entire thing is being considered here. Okay, so I can write V as V1, V2, V3, and we have to write V plus B delta is equal to F. V plus B delta is equal to F. That's the form in which we have to write. What is delta? We know it's a matrix of parameters which are A hat and B hat. Now if it is so, what is B? What will the B? To look at that B, we have to go back. So B is a matrix of coefficients of A hat and B hat. So in this equation, in this very first equation, the coefficient of A hat is -1 and the coefficient of B hat is 0. So it is -1, 0. Over here, coefficient of A hat is 0 and for B hat it is -1. So 0, -1. Then in the third one, the coefficient of A hat and B hat both are -1. So we can write -1 and -1. So that's our B. What is F? F is the matrix of constants. The constants here are -A, -B and -C. So F is -A, -B and -C. Now once we have determined this, we can now straight away find the solution. The solution for this we know can be written as inverse and B transpose WF. This is what I have written over here. That's the solution, because right now we know B, W. Well, about those observations, the observations which we had, in this case we had 3 observations, A, B and C. Do we know anything of the weight of these observations? If we know the weight, so this is the weight matrix, and then F, this is also known. So from here we know the least square solution, so A hat and B hat both will be known to us. And this is what is desired. These are the desired quantities. So again in this problem, what is important? Important thing is the very first step when we are forming the equations. As I can point it out here, this step is important here. And this. Now once we are able to write this basic model, then rest of the solution is easy. Rest of the solution is only a matrix manipulation, as you can see here. Fine. What we'll do, we'll solve the same problem now by condition equation. And in this condition equation method, we know at the moment we have n is equal to 3 and n naught is equal to 2. So our redundancy is equal to 1, r is equal to 1. And as we have seen in the case of condition equation method, we need to write one condition here. Now what that condition will be? Well, we need to write one condition, and the solution, as we know, solution follows like this. Our basic condition we have to write this way, and then we have to form the equation in this form, AV is equal to F, and then we find the value of K, and then finally we find the value of V. Well, we'll come back to this later on. Let's write the condition. So to write the condition, our observations are A and B, and that's the C, third observation. Now what is the condition here? The condition here I can write as C hat minus A hat plus B hat should be equal to 0. Is it not? Because what these are the adjusted observations or the estimates of the observations. If these are adjusted observations, then they should satisfy this condition. That's the condition. And what is this? This is in the form of F LA is equal to 0. And this is one equation because we need to write only one here. So this is the one and only independent condition which is available. So once we have written this, now we can write, or rather we can replace LA by LB plus V. We have seen this before also. So we can write it as C plus V3 minus A plus V1 plus B plus V2, this is equal to 0. And finally, as we know what we have to do, we have to write it in this form, AV is equal to F. So we will try to write it in this form, minus V1 minus V2 plus V3, this is plus C minus A minus B is equal to 0. So minus V1 minus V2 plus V3, this all equal to A plus B minus C, and this is a constant F. If I write this entire thing again over here, minus V1 minus V2 plus V3, this is equal to F. Okay, we want to write it as AV is equal to F. So our V is V1, V2 and V3. So our A becomes minus 1, and 1, and F is that particular constant, okay, which was A plus B minus C. So once we have determined A and V and F, now the rest of the solution is easy. First of all, we will find for K. Of course, we need to know what is the weight matrix also. Once we know the weight matrix, we can solve for K now. Once we have found for K, we can also solve for V. So this is what the general form is shown over here. We know now A. From the weight matrix or from the precision of the observations, we know theta, we know F. So K is known. Once K is known, we can also find the V, the residuals. Once the residuals are known, we can find our A hat, B hat and C hat as A plus V1, B plus V2, C plus V3. Okay, now we will see one more example. Now in this example, what is there? As you can see, there are 3 points P, Q and R, and the job is someone wants to determine the shape of a triangle. Okay, in order to determine the shape of the triangle, what all we need to observe? If our observations are true observations, I need to observe only 2 angles, because the third angle can be determined by the geometric condition. So the minimum number of observations which we need to fix the shape of the triangle is 2. But someone who was working in the field, what he did, he observed angle A, angle B also, angle C also. So basically A is the observation, the value for angle QPR. Okay. At the same time, he also introduced more redundancy into it. So what he also observed, he observed angle D. He closed the horizon there. So number of the observations which he has taken are 4. So in this case, the redundancy in our model is 2. Now the important thing here, what is desired here? In order to know the shape of the triangle, the desired thing is A hat and B hat. If we know these two, or we can say no, angle QPR and angle PQR. If you know these two, the third one can be determined. No means the estimate of that. So these are our parameters here, 2 parameters. Now what we will try to do, we will try to adjust this model, this problem by again 2 methods, the observation equation method and the condition equation method. So first of all, we will try to do it by observation equation method. Okay, in observation equation method, we know that we have to write the equations, number of the equations should be same as number of observations. So for each observation, we are going to write one equation. Alright, so this is what we are going to do. What are the observations here? The observations are A, B, C and D. So let us write those equations. We can write number 1, A plus V1 is A hat. And in these equations, as we have seen earlier also, in this observation equation that we are writing here, we write the equations including the observation as well as the parameter. Okay, we relate them. So how we are relating them here? We are relating the observation is A, V1 is the residual and this is the parameter. Okay, then similarly we can write for B plus V2 is B hat. Now we have only 2 parameters here, A hat and B hat, and we have to write further equations using only these 2 parameters. How we can do that? Well, we have one more observation here, that is C. In C, the residual is V3. C plus V3, this should be equal to 180 minus A hat plus B hat. Well, again we can write, because we have one more observations, that is in D. The observation D and some error in that is V4. This is equal to 360 minus A hat. The moment I am writing D plus V4, what is this? This is nothing but the adjusted values of this angle D, and of course A hat plus D hat should be 360, because over here a horizon is being closed. So A hat and D hat, they form 360 angle. This is why I am writing that D plus V4 is 360 minus A hat, because I have to write, we have only two parameters here, A and B hat. So all these equations are being written in their form. Next, we readjust them. In readjusting them, what we do, we take all the parameters as well as the residuals on left hand side and the constant on the right hand side. So we can write it as V1 minus A hat H minus A. Let me use a different color here in order to differentiate from the equations here. So for the number 1, it is V1 minus A hat is minus A. Similarly, V2 minus B hat is minus B, and V3 plus A hat plus B hat is 180 minus C, because I have taken this here, the parameter terms. Then V4 plus A hat, this A hat comes here, V4 plus A hat is 360 minus D. Well, these equations we will again rearrange them, because what we know, finally we have to form this in this form, V plus B delta A is equal to F. We have to write it in this form, where delta is a matrix of parameters. Parameters here are A hat and B hat. This is delta. And B is the matrix of coefficients. Okay? And V is the matrix of residuals. F is the matrix of constants. So in order to do it, you can see over here also. In this first equation, the coefficient of A is minus 1, coefficient of A is minus 1, coefficient of B hat is 0. So what we'll do, we'll rearrange this. So V1 minus 1 into A hat plus 0 into B hat, this is equal to, let me write as F1, the first coefficient term, because the terms here are all constants. So I am writing F1, F2, F3 and all that. Then V2 minus 0 plus 0 into A hat minus 1 into B hat is F2. Then V3, and we see with the V3 we have A hat and B hat, 1 into A hat plus 1 into B hat, F3, and then finally we have A hat here, V4 plus 1 into A hat plus 0 into B hat, this is F4. Now we write it in matrix form now. So our matrix V is V1, V2, V3 and V4. The matrix B is the matrix of coefficients, which you can see here is minus 1, 0, minus 1 and 0, 0, minus 1, 1, 1, 1 and 0. And delta is A hat and B hat. And finally F is F1, F2, F3 and F4. So once we have determined B, F, we can solve for delta. That solution we know how to do it. So the important thing is here to form these basic matrices or to write that basic model. So once we know that, we can compute now or we can determine A hat and B hat. Okay, now we will solve the same problem by condition equation method. Okay, for the condition equation method, we know there is a redundancy which is equal to 2 here, because number of observations were 4 and not was 2, so redundancy is 2. So what we need, we'll need to form 2 conditions here. Now what these conditions are? So what we have to do now, we have to look into our system of observations in our problem, and we have to find those conditions. So the 2 conditions which we can write here, and the conditions are being written in terms of, please remember that, we have to write it this way, in terms of adjusted observations or estimates of the observations. How we can write that? Well, first one, A hat plus B hat plus C hat. These are the adjusted observations of these 3 angles. It should be 180 degrees. And the second one we can write as A hat plus D hat is 360 degrees. So these are the 2 basic conditions. We cannot write any other independent conditions in this case. Now once we have done it, we replace LA by LB plus B. So let's do it. We can write it as A plus V1 plus B plus V2 plus C plus V3. This is equal to 180 degrees, and then A plus V1 plus D plus V4, this is equal to 360 degrees. So what I am doing for A, I am replacing that by A plus V1. V1 is the error in observation A. Okay, and for D, D hat is observation D plus V4. V4 is the error in observation D. So this is what we get now. Now, as we know, finally we have to reduce it to this form. AV is equal to F. To reduce it to this form, all the constant terms are to be taken to the right hand side. Alright, so we do the same thing. Well, I am writing it as now V1 plus V2 plus V3 is 180 minus A minus B minus C, as well as V1 plus V4 is 360 minus A minus D. So all the constant terms are now on right hand side. Next, what is A? We know now, we know V here is V1, V2, V3, V4, V5. This is V, the matrix of residuals. But what is A? A is the matrix of coefficients of residuals. So what the A will be? A here will be, if you look at the coefficients, let me change the color for this coefficients. Well, over here the coefficient is 1, 1, 1. Then for V4 and V5 it is 0 and 0. Again 1, 1, and for rest, for V5 it is 0, for V2 and V3 also it is 0. So I can write A as 1, 1, 1, 0, 0, 1, 0, 0, 1, 0. That is A. And what is, so this is A, V, and what is F? F is, we can say F1 and F2, where F1 is this term and F2 is this term. Okay, so this is a constant here, this is another constant, so this is F1 and F2. So what we know now, at this stage, we know A, we know F, and we know in our method of condition equations, if we know A and F, we can find K. Once we find the K, we can also find the V, and once we have found the V, we can find our parameters. Okay, so the important thing was forming these basic matrices, then rest it is simple matrix manipulation. So we can solve this particular problem by condition equation method in this way. Okay, now we'll solve the same problem by condition equation method. Now in this case, we know that we had n is equal to 4 while n naught was equal to 2. So redundancy is 2. So we need to form two conditions here. Now what are those conditions? So we'll look into our system of observations and what is desired. Is there any geometric condition? Is there an observation condition? So we need to look into that and we need to find those conditions. Well, the very first condition we can write as A hat plus B hat plus C hat. This should be equal to 180. Well, A plus B plus C, this is not 180 because A, B and C, these are the observations and these observations have got some error. But A hat, B hat and C hat, they are the estimates of the observation now, adjusted values. So they do not have any error. So that is why that's the first condition. And the second condition can be written as A hat plus D hat is 360 degrees. So these are the conditions, two conditions. Now what is this a form? This is of the form FLA is equal to 0. Now we need to replace for this adjusted observation as LB plus V. Now let's do it. So I can convert this as now A plus V1 plus B plus V2 plus C plus V3, this is equal to 180. What I am doing, I am replacing A hat with A plus V1. Similarly, A for the second equation, A plus V1 plus D plus V4 is 360 degree. So V4 is the error in observation D, alright, or the residual for that observation D. Once we have done it, because finally we need to write this in a form AV is equal to F. We need to write it in this form, and where F is the constant term. So all the constants needs to be taken on the right hand side. So I will take these constants, A, B, C to the right hand side. Now in taking these to right hand side, we can write it as now, these are the basic equations which we are writing here, okay, same, and by taking these constants to the right hand side, we can write V1 plus V2 plus V3, this is 180 minus A minus B minus C, and V1 plus V4, this is equal to 360 minus A minus D. Let us say this is F1 and this is F2, the constant terms. Further, because finally we have to have in the form of AV is equal to F. Now V, what is V? V is a matrix of residuals, which is V1, V2, V3 and V4. Because we have 4 observations, so we will have 4 residuals and this matrix V. Now what is matrix A? A is the matrix of coefficients of these residuals. So over here, if you see for matrix A, the matrix A can be written now as, if I write the coefficient is 1, 1, 1 and 0 and 0 for, 0 for V4. Over here it is 1 for V1, 1 for V4, 0 and 0 for V2 and V3. So I can write it as 1, 1, 1, 0, 1, 0, 0 and 1. So that's A. And so we know F is F1 and F2. So at this stage we know A, we know F, we can find now K. So K can be determined Once the k is determined, we can find v. Once the v is determined, we can also find the LA. LA is LB plus V. Alright. So our adjusted observations are known. Once you know the adjusted observation, we also know now that means A hat and B hat, our basic things, basic parameters which define the problem. So we know now the shape of the triangle. So this particular problem has now been adjusted by condition equation method. Okay, now what we will do, we will see the adjustment of base quadrilateral. We know what is the base quadrilateral. We have seen that when we are talking about the triangulation, and we will do this adjustment by condition equation method. Now a base quadrilateral, as you can see here, has A, B, C and D. These are the triangulation stations, and from these triangulation stations, the thing is here, we know one of the lines. This line is known from previous triangulation, or it has been measured, or maybe known from the previous triangulation. So this is known to us. What we want to do, this point is fixed, this point is fixed, and we want to fix B and C. Now in doing this, we observed 8 angles: theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7 and theta 8, and this length is already known. So total number of known quantities or observed quantities we can say is 9 here. Now a little bit about why we need the base quadrilateral. Basically what we are doing here, because we know the point A, let us say, and point B. These 2 points are known, so this length is also known. And by observing these angles, we are aiming to establish point C and D also. We want to find the coordinates of C and D. And this is very important, when we are doing the control survey, we are extending the control. So by knowing this length AB, or maybe we know the position of A, we know the position of B, we can now, by taking these angles into account, we can compute the position of D and position of C. Now in a base quadrilateral, why there is a need of adjustment? Why we need to adjust it? Let us see. Our aim is, as we are looking at, in a base quadrilateral, because this line is known, what are the way, and in order to fix point D and C, this is A, B. In order to fix point C and D, what is the minimum number of observations that we need to know? The minimum number. Well, I can fix D for this figure by knowing this total angle, and by knowing this angle, I can fix point D. So I need to know this length, this angle and this angle. So 3 observations. Plus, in order to fix C, I need to know the angle here and the angle total one. So I can draw this by a different color. To fix C, I need this total angle and this angle. So the length is already known. So plus 2 observations. So what we need to know, in order to fix D and C from known length, we need to have a total of 5 observations. 5 means 4 angles and 1 length. This length and 4 angles. So right now I am saying, well, I need to know the angle here alpha and the angle beta. This full angle is beta. If I write it in the blue color, this angle is the beta, the full angle. And here this small angle is, let's say, gamma. and this big angle is theta. So basically what we need to know, in order to fix B and C, I need to know one length AB and angle alpha, beta, gamma and theta. So we should have these 5 basic observations. So we say n naught is equal to 5. Okay. Well, what actually we do, as is seen in this particular figure, because only 5 observations can solve our job, but in that will be a unique solution and we will not have any control on the error. So what exactly we do, this length is known to us. We also take now several angles. We take all these angles. So rather we are observing one length AB plus 8 angles. So how many observations we have taken here? In order to do this Brice quadrilateral, we have taken 9 observations. So from here we know the redundancy, because n is 9 here. So redundancy here is n minus n naught, that is 9 minus 5 and that is 4. Why this redundancy? Because we took extra angles. We took, these are the extra angles. Even if we don't observe these angles, just by knowing the length here and these angles, the problem can be solved. So we have a redundancy of 4 here in this particular problem. Because we have the redundancy, so we would like to go for the best possible solution. One more thing here. In a Brice quadrilateral, as we have observed, angle 1, 2, 3, 4, 5, 6, 7, 8, and all these angles have some error in them. Well, if I adjust, for example, let us say a triangle, I give them name A, B, C, D. If I adjust only the triangle A, B and D, if I adjust them, well, I will have 1 plus 2 hat, 3 hat and 8 hat, the adjusted values. If I adjust triangle which is B, C and A, then I will have again 2 hat, 3 plus 4 hat and 5 hat. So what we are seeing here, if I adjust this Brice quadrilateral in parts, okay, I am adjusting only this triangle first. I have the adjusted values of the observation inside. Then I can also adjust this particular triangle. Now the angle, for example, the angle number 2, it has a one value here and one value here. So angle number 2 is being adjusted in 2 different ways. So it will have 2 different values, which is not possible. So what I mean to say, we cannot adjust this kind of problem in parts. Rather, we have to take all the observations together. We have to form one system. In that system, all the observations should participate. So whatever the conditions are there, the conditions should be satisfied. It's not that we are adjusting them in parts. Well, so we know now, in this case, n naught was 5, n was 9, r was 4. So we need to form 4 equations, okay, or the 4 condition equations. Now what these condition equations will be here? The condition equations will be, as you can see over here. Can we form some angle conditions? Well, let us say, and again, these 4 conditions should be independent. So first condition equation we can form as theta 1 plus theta 2 is equal to theta 5 plus theta 6. Okay, so theta 1 plus theta 2 is theta 5 plus theta 6. Of course, all these are the adjusted values. So I am putting hat. Theta 1 hat plus theta 2 hat is equal to theta 5 hat plus theta 6 hat. Similarly, theta 3 hat plus theta 4 hat is theta 7 hat plus theta 8 hat. What I am doing, this plus this is this angle plus this angle. Well, I can write one more equation which is independent of these, that is theta 1 hat plus theta 2 hat plus theta 3 hat plus theta 4 hat plus theta 5 hat, theta 6 hat, theta 7 hat plus theta 8 hat. This is equal to 360. So this is also one more condition that I can write. So using the angles, I can write only 3 independent conditions. Now what is the fourth one? Because we need 4 conditions. Okay, what is the fourth condition now? So these 3 conditions which we say angle conditions, these are the angle conditions which we have just written here. These are the angle conditions. Well, we need to write one more condition now, and that condition we say as side condition, not line condition, it is called side condition. Now what that side condition is, the side condition takes into account the length, or rather the figure is closed, because you know this figure needs to be a closed figure as it is in the field. In the field we have 4 stations, and those 4 stations, they form a closed figure. So we have to ensure that our angles are such that they form a closed figure. Now how do we ensure that? Let us say it is A, B, C and D. That's our quadrilateral. I can do one thing. We can write here B, C in terms of AB as, using the sine rule, sine of BC. So sine theta 8 divided by sine of the angle in front of AB is theta 5, isn't it? And of course these are the theta 8 hat and theta 5 hat. The figure will be closed not for the observations but for the adjusted observations. That's why I am using theta hat. Well, now I can write DC. DC in terms of BC. So I can write it as DC BC sine theta 6 by sine theta BC. Well, I replace BC over here, so I get AB sine theta 8, of course hat everywhere, sine theta 8 and sine theta 5 hat sine theta 6 hat sine theta 3 hat. If we continue this process, and because right now you know we started, we are writing BC in terms of AC, then we wrote DC in terms of BC and replace this BC by AB, okay. And then if we continue doing it and finally we reach again at AB, so what we can do, we can write AB again in terms of AD and sine of the respective angles. So what we get by doing this, we get AB is AB sine of theta hat, sine theta 8 hat and sine theta 6 hat, sine theta 4 hat, sine theta 2 hat, sine theta 7 hat, sine theta 5 hat, sine theta 3 hat, sine theta 1 hat. This is what we get. And AB and AB, they will cancel out. So we can write this as now, if I take it here, so sine theta 7 hat, sine theta 5 hat, sine theta 3 hat, sine theta 1 hat is equal to sine theta 8 hat, sine theta 6 hat, sine theta 4 hat, and sine theta 2 hat. Well, I take log of both the sides. So taking the log of both the sides, I can write this as now. If you look at this, this is 7, 5, 3, 1. What kind of angles are these? Look at the figure here. 7, 5, 3, 1. If I stand at this point B, this angle 7 is towards my left hand side. If I stand at 7, 5 is towards my left hand side. So what I do, sigma log sine of left hand angle. This is equal to sigma log of sine right hand angle. Okay, because these are the right hand angles and these are the left hand angles. I can write it like that. And of course, the adjusted value, I can write it further as sigma log sine L hat minus sigma log sine R hat, that equal to 0. This is the fourth condition, because we had three conditions which are coming from the angles, and this is the fourth condition which is coming from the sides. So we say this is as the side condition, and this ensures that the figure is closed figure. Okay, so these are our four conditions now. Three angle conditions, all right, and one side condition. So these are the four conditions which we will use for adjustment. Now we know in the condition equation method that we have to replace LA by LB plus V, and this is what we will do now. To replace this, so we can write for theta 1 hat, theta 1 plus B1, for theta 2 hat, theta 5 hat, theta 6 hat, theta 3 hat, theta 4 hat, theta 7 hat, and theta 8 hat. And this is what we have to write, theta 3 hat, theta 4 hat, theta 7 hat, theta 8 hat. So this is being reduced to the equation here. Okay. Similarly, this is sum of all the angles is equal to 360. So for all the angles, sum of all the angles plus sum of all the residuals. Okay, so these are the observations now. This should be equal to 360. So what we are doing, we are replacing LA by LB plus V. This is what we are doing. And the same thing can be done also in the side equation. We will have to do that. And the side equation takes the form of, as I have written over here, the various terms are log sine theta 1, this theta 1 is the observation, cot theta 1 V1. We are not getting into this, that how we have arrived at that, but this is what, once we replace the adjusted observation with actual observation in the field plus the residual, the side equation reduces to this. Similarly, the second term, minus log sine theta 2 minus cot theta 2 V2, and so on. This is equal to 0. So please write it down yourself, then only you will understand it. And once we have reduced it this way, the next step is we need to have our basic model in this form. We know it. So we need to know A, we know V, and we need to know F. Now what will be A here? If you look at A, this A will come from the coefficients of V1, V2, so on up to V8, the coefficient of these from these equations. So from the very first equation, the coefficient here is 1, 1 and -1, -1 for, and for theta 3, theta 4 it is 0, 0, for theta 7 and theta 8 again 0, 0. So how we can write it? 1, 1, 0, 0, this for theta 1, sorry V1, V2, V3, V4, V5, V6, V7 and V8. So these are the coefficients of V1 to V8. Similarly, you can see for this third equation. In the case of the third equation, the third condition equation is, these are the terms, V1 to V8 are the terms here, and the coefficient for all of these is 1. So it is 1, 1, 1, 1, 1, 1 and 1 and 1. Similarly, for the side equation or the side condition, the coefficients of V1, the coefficient of V1 is cot theta 1, coefficient of V2 is minus cot theta 2. So this is what we are writing here, cot theta 1 minus cot theta 2, cot theta 3 minus cot theta 4, cot theta 5 minus cot theta 6 and so on. So we know A here. We also know V. V is V1, V2 and up to V8. That's V. And what is F? F, again it can be determined from here, because all these constant terms, you know, theta 1, theta 2, all these are coming to the right hand side. So we can determine the value of the constant. For example, here the constant will be 360 minus sigma theta I. So this is the constant term. So we know the constant term also. So that's V, and these are the constant terms. Theta 5 plus theta 6 minus theta 1 plus minus theta 1 theta 2, this and this. So we know this, we know A. So A and F are known. Once A and F are known, we know how to solve for it. We can find for K, then from the, once we know K, we can find for V, and once the V is determined, we can find the values of theta 1 hat, theta 2 hat and so on, theta 8 hat. All these adjusted observations can be determined. So what we have seen, you know, the base quadrilateral can be also adjusted by this condition equation method. So in this lecture we saw some examples. We solved one simple problem or two simple problems by both the methods, observation equation method as well as the condition equation method. Then later we saw about the base quadrilateral. We also discussed this question, why it is required to adjust it, what is the use of the base quadrilateral, and then the procedure of adjusting it by condition equation method. So basically the important thing is to form that basic model. Once the model is formed, we have the matrices, and it is simple matrix manipulation. Thank you.